Hi everyone. I want to talk about centripetal acceleration here. So you know that Newton's first law states that an object that moves on a straight line had a tendency of going on a straight line unless there is an external force changing its direction or its motion total. So we have a straight line motion unless there is no interruption from around. Therefore, when you look at a circular motion or rotational motion, you see that the velocity of any point on that circle that I drew here as v1, v2, and v3 at different points of the circle, anything that rotates around the circle, or let's say this is a running path and you're just running, which means that at this point you're pointing toward it this way, and at this point you're pointing toward this way. So each point on the circle is going to be, you're facing it at different directions, which means you're changing your direction. And where does that change in direction comes from? So here I basically try to give you the difference between each point's velocity. So the speed of the rotation of the object doesn't change in a circular motion. However, the direction is changing. So that is what we call uniform circular motion. At every point on the circle, you have the same speed. However, the direction is different. Therefore, the velocity is different. And you know that what we call change in velocity, it's acceleration, right? So if something is changing direction in velocity, so therefore the velocity is changing, we call that change acceleration. And in the case of a circular motion, we call it a centripetal acceleration. And its value is equal to the speed square, the motion's velocity square, divided by the radius of the circulation, where you have the radius defined here. So what does it mean, this centripetal acceleration? So this is basically the acceleration that your object needs to stay on the circle with that speed. That's what it means. So if you're observing an object rotating around this radius with this speed, v, let's say every point has the speed v, it means it's being basically pushed toward in with the force that is associated with this acceleration. So if you remember, force is equal to ma. So therefore, centripetal force is equal to mass of the object that is circulating times the acceleration, that is centripetal acceleration. Okay, so when you observe an object circulating around this radius with this speed, it means the force is being pushed toward the center of rotation, which is the center, is equal to this value, the mass of the object times speed squared divided by the radius of rotation. So whenever you see an object doing this uniform circular motion, you know that a force is changing its direction from this point to the next, to the next, to the next. At every point on the circle, there is a force pushing this object toward the center of the rotation to change its direction. Otherwise, it would go on a straight line, which is basically the beginning direction, right? So this is what we call centripetal acceleration. So in different setting, we will have a source of centripetal acceleration from different um, different forces, such as if you have a car driving around a curved path road, it could be tires friction with the road. If you're talking about, for example, sun, all the planets are rotating around the sun, including Earth, right? In that case, it's going to be whatever the planet, let's say, it's the mass. So there's a gravitational force that is attracting all the planets towards sun to keep them around the sun in a circle. Our path is not perfectly circle, but it's very small elongation actually that makes it ellipse. But in any case, it can be called approximately a circular motion. So you can say that the centripetal force that Earth is experiencing, which basically causing Earth along this path every moment to change its direction from this way to this way, is the gravity between the sun and Earth. Okay, so In the case of the car, again, it's the friction on the tires. If you think about the pendulum experiment that was swinging back and forth, right? So in that case, it's the tension on the core that basically keeps pushing this mass toward the center of rotation, because this is kind of a whole circle if you think about it, if you imagine. It's just the arc of it, and I mean, you can make it a whole circle. You can basically attach a mass at the end of a string and make it circulate around the center. That would be uniform circular motion. In that case, it's the tension on the cord. In this case, it's the gravity. In the car case, it's the friction. I mean, there are different settings. In the case of atomic, structure has electrons rotating around the nucleus. So in that case, it's the electromagnetic forces. So there's different forces depending on the setting that keeps the object around the circle. That means like a force that is equal to what is needed. So this centripetal force is basically what the object needs. It depends on the mass of the object, speed of the object that it's going to be circulating around, and the radius of the path. So this is the magnitude of the force this object needs to stay in the circle with this speed, this radius exactly. And the source of the centripetal could be gravity, could be friction, could be tension, depends on the setting again. So I hope this helps to understand centripetal acceleration along with centripetal force. But I believe it might be tricky to see different settings have different source of centripetal force, so I tried to clarify here. Let me know if you have any more questions.